Okay, and so the next example now is number 14, okay? In this one, now it's a radioactive isotope they're given to us, right? Cobalt 60, it tells us we have an initial quantity of 50 grams. The half-life of it, remember, I'm using T sub 1/2. Remember, that was the notational device we were using for the halving time. 5.27 years. The first thing they want us to do is they want us to find the decay constant, or the decay rate, K. All right, so in that regard, if you recall, we know that this is true. Okay. In fact, in a previous video was something that if you recall, I asked you to develop that on your own. Okay. So what they're telling us, gang, is that this fraction is equal to 5.27. Now solve this equation for K. They specifically said, I believe, use 4 decimal places accuracy. Okay. So solving this equation for K. Okay, so negative 0.1315. Okay. Part B, it says find the amount after T years. Well, what they're really saying, gang, for part B is find, like, write the formula for it. Write the exponential decay model. From our previous work, we know that they're asking us for this, okay? Loosely, not loosely, but what they're saying is drop that number in A sub 0, right? That's 50 right here. Drop in K, that's this value right here. All they're asking you to do, gang, is like put the pieces into the formula. That's it, okay? So here, okay, just like that. Then the third part is it says, how long does it take for 90% of the initial quantity to decay? Okay, and now what that really means is, okay, remember, what did we say that this expression over here means? It's the amount after a certain number of years. So what they're really saying is if 90% decayed, how much is left? 10% is left. So after how many years is 10%, 0.10 of the original quantity going to be left over? So part C, maybe we'll put that over here. Okay, so notice what we're doing, right? This is the amount left over a certain amount of time. What we're doing is we're forcing that equal to be 10% of the original amount. Remember, 90% decayed, so how much is left? 10% of the original amount. You'll notice, gang, notice I put the value for K over here. I left it out. What I'm going to do is, rather than carry this over, I'm going to wait till the very end, and then I'm going to plug this number in when we get to the final calculation, just in the interest of space, okay? All right, now, solve this equation for T. I'm going to divide the 50 out from both sides. Okay. Once again, I'm going to appeal to this very special relationship and say that the equivalent logarithmic equation for this exponential equation is this one. Okay. From here, I can divide both sides by K to isolate my time. Okay, so divide out the K from both sides. Now, into the calculator with this. Okay, and calculator gives us about 17.5 years. Okay, so another example of exponential growth and decay models, but just in case you got tired of doing the compound interest, a little something different over here. Okay, all right, gang, take a look at this, make sure you understand how all of this worked out, and be sure to send emails if you've got questions.